so could you give us just like a lightning round version? What are the pros and the cons to each of these? If someone's trying to figure out the best solution for them, what are the high points and the low points of each for the different options you just gave?
Okay. For the shotgun mic, they're relatively inexpensive. I mean, you can get extremely expensive shotgun microphones, but there are reasonably priced alternatives. They are relatively small. I mean, you've seen them on top of cameras and so forth. You can find them relatively everywhere. They also provide a very natural sound when the source is directly in front of the microphone. It does get colored or become biased, if you will, as it moves off axis of the microphone. On the con side, on the downside, they aren't as directional as most people expect for the normal, let's say, human voice frequency range. They'll go up to 60, 70 degrees off of center line before you really see a significant fall off in their pickup. The other thing is they really are not providing any amplification. It's strictly electronic amplification, which, as we mentioned, can lead to noise and hiss and so forth and so on. So that's the shotgun mic. As far as the parabolic microphone, they are very directional, probably one of the most directional options. They provide a significant mechanical amplification.
Can I pause you? What is you said that shotgun mics go up to 70 degrees or something off of the main target line. What sort of is the degree range for parabolics then?
From our testing, we're seeing 30 or 30, maybe 40 degrees, depending on what frequency range you're looking at. At extremely high frequency ranges, they're like 5 degrees off the center. So it really depends on the frequency range, but we would say at least twice as smaller, half the angle off of the center axis as a shotgun microphone. On the downside, they are relatively large. So if, let's say, you're someone hiking this off into the woods or wilderness, it's going to be a relatively large object to deal with. And probably the most common or well-known issue is that the audio is what we call colored. It will have a bias toward the high frequencies because high frequencies reflect better than low frequencies. More of the low frequencies are absorbed by the dish than at the high frequencies. So there will be a certain unnatural, or in the extreme case, you could call it tinniness, but that's only if you have a poorly built, poorly constructed parabolic, that it should get to the point of being tinny. As far as, I'm sorry?
What sort of size range are we talking about? You were talking about how big they get. Are they all that big? What are the different, size just differences between them?
Okay. Clover Products offers 3 sizes, our smallest being 9 inches in diameter. Then we have a 16-inch in diameter that is actually used quite often when portability is an issue, where you're going to be, flying it all over the world or carrying it into the wilderness and so forth. And then our largest unit right now is 26 inches, which is what you see at football games almost exclusively. And we are in the process of working on a unit that would be probably 38, 40 inches in diameter. But that would, at that size, it has to be broken down into pieces just for, reasonable transportation. But that's something that we've been working on, and every day we hope to get a little closer to that one. Okay, going back to your question, as far as microphone arrays, the great point of a microphone array is they can really focus in on a particular sound source using the computing power of the computer. Again, they take into consideration the time difference from when it reaches one microphone element versus another, and then they can concentrate on just the sources from a certain area. The downside is that they're pretty expensive, and you're dealing with a lot of computer hardware, so they're complex, and all the issues that come along with having a computer, downtime, upgrades, all that sort of thing. As far as laser microphones, again, the audio can be captured from great distances because the laser has an unbelievable range. They shoot lasers to the moon and bounce it back to see exactly how far the moon is away. But again, the downside is the alignment. The further away you are, the more critical that alignment becomes. They're expensive and complex. You have a lot of electronics involved with turning that movement of the laser beam into an audio signal. So there's a lot of pieces involved, and it's relatively complex.
Is there any upcoming technologies that you've ever heard of or anything like that to further enhance what we're able to do sound-wise over long distances, or is this probably where we're going to stay for the next 100 years?
Oh, 100 years is a long time. The trend right now, at least in the sports market, is putting more and more microphones on the players. The problem with that, to be quite honest, the biggest problem is just stadiums are running out of radio frequencies. If you go to a big, Super Bowl or playoff game or whatever, they'll have people that are just dedicated to tracking down stray radio frequencies, so somebody doesn't get on a walkie-talkie out in the parking lot and interrupt the television broadcaster's microphone or something like that. So the more wireless mics you have, the more frequency problems that are involved. The other thing is the players really don't like being mic'd up all the time. I've at least heard stories, let's put it that way. I've heard stories where the microphones would be returned to the television people with athletic tape wrapped around them and things like that. Some players have complained that their injuries were increased because of the transmitter pack that they were wearing. So there's a lot of issues with that. But that's, at least for right now, that seems to be the trend in the sports world. Obviously, for wildlife or security type applications, you can't ask the gray wolf that you're filming to wear a wireless mic or anything like that. But that's the trend in the sports world right now.